Hello guys, welcome back with me, Wayan and Wedana. Okay, here I will give you an explanation of Newton's second law. Well, without much to say, let's get straight into the learning material. First, let's read Newton's law first. Let's go to the next picture. Newton's second law. So, the acceleration of an object is directly proportional to the resultant force acting on its anniversary proportional to its mass. Understanding Newton's second law states the acceleration experienced by an object is proportional to the resultant force acting on the object, but inversely proportional to its mass. This statement means that the greater the force acting on the object, the greater the acceleration curve. Maybe the lens width is not good to hear. I will explain with the picture. Let's go. There are two people pushing a car with a force F. The first person pushes a car that has a mass of 700 kilogram, and the second person pushes a car that has mass of 2,600 kilogram. You can see for yourself which car is faster. Yes, it's the first car because the first car has a lighter mass than the second car. Okay. Newton's second law states the external force that causes the object to accelerate its value is directly proportional to the resultant force acting on it and inversely proportional to its mass. Not, not. Newton's second law states that the magnitude of the acceleration is directly proportional to the net force acting on the object. So on the object, so what is the total force and how it's calculated? Okay, we will see how to calculate the resultant force in the next picture. The net force, the sum of all the force acting on object in a given direction. Since force has direction, it's a vector quantity. A vector quantity is a quantity that has both a value and a direction on paper. The direction of force is often symbolized by an arrow. For example, suppose an object is pushed to the right with a force of 10 Newton and to the left with a force of 5 Newton. So so the net force acting on the object is 10 minus 5 equals 5 Newton to the right. Okay, continue the second picture. You can see there is a tire that has a wide V and is pushed with a force F. Oh, sorry guys. Okay, continue the second picture. You can see there is a child that has weight W and is pushed with a force F. It's roll on a inclined plane that has a hand height h and a distance s. From this picture, we can find the problem. You can calculate the speed of the tire using the formula v root of 2 g per k plus a. You can calculate it yourself. Yes, this is a form of applying Newton laws in everyday life. You are already familiar with this kind of thing. Okay, next. This is a package. This is a picture like the problem above. We are asked to calculate the resultant force. You already know. I don't need to explain anymore. Next, this is a Newton law formula 2. F sigma F equals m a. F equals force, m equals object mass, a equals acceleration. Okay, let's just go straight to the application of Newton's second law formula in the following problem. Sample question. Two objects of mass 1 and mass 2 are shown with a smooth pool as shown in the picture. Then the magnitude of the acceleration of the system and the tension is the rho T. T is rope tension. Sigma F equals m times A. T mean WE equals mass 1 times acceleration. This is W is weight. T equals m1g plus m1a. This is equation 1. Sigma F equals m times A. W2 minus T equals m2 times A. m2g, this is gravity. m2g mean T equals m2 times A. This is equation 2. Substitute equation 1 and 2. By substituting equations 1 and 2, we get acceleration equals m2 minus m1 times gravity per m1 plus m2. Next, T equals m1g plus m1 times m2 mean m1 times g per m1 plus m2. And this is mass, object mass. T equals m1 times m1 plus m1 times m2 times G in the room per M1 plus M2 plus M1 times M2 mean M1 times M1 times G per M1 plus M2. And then T equals to M1 M2G per M1 plus M2 times G, and then enough. That's all my explanation of Newton's second law. Thanks for watching and see you next video.